Good morning, Algebra 3 class. I hope you have been having some good times there and enjoying seeing the sunshine and the beauty out there. So try to notice that every day. Let's jump in today and work on adding and subtracting radical expressions and reviewing those properties. Some of it's review, some of it's new, but I think you'll find that it's not too bad. We are kind of hitting the home stretch here, so be encouraged with that. And let's just make sure that we finish up what we need to finish up. Okay, so adding and subtracting, just like when you have just variables, you're looking for terms that are like each other. Okay, so in this case, in order to put your terms together, they have to have the same index and they have to have the same radicand. Okay, the index, the number here, and the radicand, the number underneath. If they don't have both the same index and same radicand, you can't put them together by adding. So for example, this one can go together, same radicand, square root of 5s. So, okay, here once again, radicand, same index. We're counting cube root of 6s, so 2 minus 5 is negative 3 of them. But when you have something like this, I have the same index, so I can't put them. That one's already simplified. These are different, even though the radicand is the same. And here the indices are the same, but the radicands are different, and can't put them together by adding or subtracting. Now we know that we did some things with multiplying and dividing. That's different. But today we're talking about adding and subtracting. Adding and subtracting is a little more precise on that. Okay, now these appear to have different radicands, but before you can decide and make your final decision whether you put them together, you do need to simplify. So remember we did the factor tree thing where we simplified? We need to do that again. So if I factor 23 times the square root of 24, 24 breaks down here. We have a pair of 2's, so a 2 can come out. And here we've got a pair of 3's when you finally factor this out. So a 3 can come out. Here's my factored form. One pair of 2's means a 2 can come out. One pair of 3's over here means a 3 can come out. And then you can simplify after you've brought out the common factors. 3 times 2 is 6. 2 times 3 is also 6, so I've got my 6 square root of 6 and my 3 square root of 6. Now I've got the same index, the same radicand, and I can put them together, and there are 9 of them. Okay. Looking back over here, the little disclaimer that x has to be bigger than or equal to 0 because you can't have a square root of a negative. We want to simplify these things. So we can notice that this is 2 times 2 times 5, and this is 3 times 3 times 5. We have a pair of 2's here, so 1 comes out, and a pair of 3 here, so 1 comes out. Then we have our pieces that are in common, our common radicals. So you can combine these by subtracting because 4 of them minus 3 of them gives you 1 of them. And we have that simplified down very nicely. Okay, so your rules basically are simplify your radicals and then put together whatever matches. Okay, so sounds simple. You're doing it one step at a time, just like you've always done. Now we do have to be careful though, because here's a common thing that sometimes messes people up. Square root of 9 plus 16 is different than the square root of 9 plus the square root of 16. Yes, when you have multiplication, you can put them together like this, but it doesn't work for addition. And I'll give you a quick example here. Square root of 9 plus 16, when it's all grouped together, is the square root of 25, which gives you 5. This one, the square root of 9 plus the square root of 16, square root of 9 is 3, and square root of 16 is 4, which gives you 7, two completely different answers. So don't get fooled and start applying your multiplying rules to your adding problems, because they just don't work. So be careful with that. All right. Remember cube roots? Cube roots, you're looking for groups of 3 rather than groups of 2, so we can use the same basic process. This is 2 times 2 times 2 times 2, 4 of them. And this is 2 times 3 times 3 times 3, if you were to factor that down. There's a group of 3. We're looking to match the index. A group of 3 2s, so 1 can come out. A group of 3 3s, so 1 can come out. And they're both left with a 2 underneath of the radical that has an index of 3. Simplify. So we have 4 and 15, and then you can subtract because same index, same radicand, same index and radicand. So putting it together like that. So definitely you have to simplify. So let's look at another one. Okay, this one does not really break down any further, because look, you've got the 2. That one is a smaller exponent than the index, and 1 is a smaller exponent than an index. This, though, has some things that can break down, because the square root of 8, the cube root of 8 is 2. This one would be 1 comes out and 2 are left if you think about that dividing method. And this one brings out 1 and 1 is left underneath. Here, let's look at that a little slower. When we factor this out, there's a group of 3. Okay. X to the 5th, 5 divided by 3 is 1 with a remainder of 2. 4 divided by 3 is 1 with a remainder of 1. Then we notice that these match up, so that's good. Same index, same radicand. The problem is that these things do not match up, so we can kind of bring them apart. We're kind of unfactoring here and have 2 plus 2xy and break it down like that. Now some of you might say, wait, there's also a 2 in common. There sure is. So if you put this down as 1 plus xy times 2 times this, that's also fine. Okay? Let's take a look at this one. Once again, simplify as much as possible. Square root of 4 is left over. This breaks down here with 6 2's. So come out, you've got the come out and 1 that's left over inside. Once we've simplified all that, it can't go together because the index and even though the radicands match, and even though it seems to have a lot in common, we're just going to leave that alone because the indices don't match. Everything has to match. Okay, what about fractions? Everybody's favorite. We're going to combine radicals with fractions, so that makes it super fun. So sometimes it's good if you have an entire big radical to break it down into numerator and denominator, but sometimes when you have a numerator and denominator, it's easier to put it into one big radical. So this problem shows both of those things happening. Okay, 75 over 16 doesn't reduce. So our first inclination for this is going to break it up into numerator and denominator. But when you do a quick look over of this one, okay, 8 and 32, that fraction does reduce. So if the fraction does reduce, you want to put it together so that you can reduce it. It makes any fraction that can reduce makes things easier in the long run. So we've got that here. So when I start to evaluate, okay, this one, I'm breaking it down into 3 times 5 times 5 so that I can simplify. Square root of 16 turns into 4. 8 over 32 reduces to 1/4, which, like I say, makes things a lot easier for you. Because yes, we could square root this, we'd just end up with a lot more work to do, but since I can do this first, I'm just going to be taking the square root of 1 over square root of 4, which makes it easier. Okay, here a 5 pops out, and here, interestingly enough, we get just a half. Square root of 1 is 1, square root of 4 is 2. Now this is a strange thing too, because we're always so quick to want to reduce, but you need to think about what's happening here. This is 4 over 2. And most of you will just automatically say, well, make it into a 2. But since we're looking to make this into one fraction, we would need common denominators anyway, so leave that 2 alone. And then put your numerators together and it has the same denominator. Okay, so be careful when you're thinking about reducing not to reduce too quickly and too automatically. Okay, at the end you would always want to see if there's something that can reduce, but sometimes in the middle you don't need to. Okay, all right, so being a little strategic about whether you make it into a fraction with one big fraction radical symbol, or you break it down into numerator or denominator. All right, last one for the day. We have both cube roots, so that looks promising. We have fractions that don't reduce, so we're going to want to make it into a numerator and denominator situation. And then we need to go about the business of simplifying. So when I simplify this and try and simplify this, they don't break down. This is only 2 2's, so not enough to come out. This one doesn't have enough to come out. This, however, turns into an x squared. Okay, 6 divided by 3 is x is 2, so x squared. And this breaks down into an x cubed. Now notice that I've got these little boxes here because I didn't want you to see too much. We need common denominators here to put them together. This is a squared, this is a cubed. So our common denominator means that this one needs another x to make it into a cube. So what I need to do is multiply numerator and denominator both by x's. Because you can always multiply numerator and denominator by the same thing for equivalent fractions. So we have this now. Okay. Now, we have common denominators, which means we can combine this numerator. What we notice is that our index and our radicand don't match. We have the same index, different radicand, so we have to leave it separate. But we have broken it down, we have found our common denominators, and we have put it together as completely as we possibly can. So there's your going back over adding and subtracting radical expressions from what you had in Algebra 2, but then also adding some aspects to it that you may or may not have seen before. So you're going to work on your assignment and then have it ready to turn in on Monday. And on Monday, you will have available to you your quiz on sections 1 to 4, which you are allowed to work together on, and that will be due at the end of the class period on Tuesday. And we will, I'll be getting back to you on strategy for next week, and you'll be able to see what the plan is for next week. All right, so you have a really wonderful, blessed weekend. God bless you.